Hello students, in this video we'll prove that a limit of a function of two variables doesn't exist by looking at different trajectories approaching the origin. Let's show that the limit as xy tends to 0, 0 of x squared sine y over x to the fourth plus y squared does not exist. Okay. And we'll approach this as we typically do by looking at several different trajectories. So here are our trajectories. There's the x-axis, there's the y-axis, and I'm going to look at trajectory number one. Trajectory number one is just going to move along the x-axis. This is my first trajectory, trajectory number one. And trajectory number one is just parameterized by saying t comma 0, and we're going to use a little bit of abusive notation. I'm going to say it starts at t equals 1 and goes to t equals 0. Even though this is mathematically nonsensical, it's designed to be the notation saying I start at 1 and I tend to 0. So that's my first trajectory. So along trajectory number one, we're going to have the limit as t approaches 0 of what? Now my x is equal to t and my y is equal to 0. So I'm going to have a t squared sine of 0 over t to the fourth plus 0 squared. Now the sine of 0 is 0, so this limit is identically equal to 0. So along trajectory number one, the limit is equal to 0. So over here we have a 0 limit. That's a 0 limit over here. Let's look at trajectory number two. So trajectory number two, let's go over here. So trajectory number two, we'll go along the y-axis. Okay, that's trajectory number two. And how can I think of this? This is going to be 0t, where t goes between 1 and 0. So that's my second trajectory over here. So let's look along trajectory number two. So along trajectory number two, we have the limit as t goes to 0 of what? Now my x is equal to 0, so we have a 0 squared sine of t over 0 to the fourth plus t squared. Again, I have a 0 squared in the numerator, so this limit again is 0. So along both the x and the y-axis, the limit of this function is equal to 0. Now, as we've seen from other examples, the next sort of most elementary way to go to the origin is along a straight line. So let's do that. So let's look at this straight line over here. That line is going to be what? That line is just going to be t comma t, t comma t. This is going to be our third trajectory. And of course, again, abusive notation, t goes between 0 and 1, starting at 1 and going to 0. All right, so along trajectory number three, what do we get? Or along trajectory three, we get the limit as t goes to 0 of what? I'm going to have a t squared sine t, all divided by what? T to the fourth power plus t squared. Now there's a common factor of t squared. Let's cancel that t squared out of everywhere. This will just be the limit as t goes to 0 of the t squareds cancel out a sine of t in the numerator, and in the denominator I'll have a t squared plus 1. Now as t goes to 0, I have the sine of 0 on top, and then I have 0 squared plus 1. So the top goes to 0 and the bottom goes to 1. So this is going to be a 0 over 1. That's well defined, and the answer is 0. So even along this trajectory over here, we have a 0 limit. So it seems to me that the limit could be 0. However, the condition for a limit to exist is that it has to go to the same value along every trajectory. We've just tried 3. Now I always try to match exponents here to make this sort of the right form. So actually it turns out if y was equal to x squared, then I'd have 2x to the fourth in the denominator. So I'm going to try one more trajectory. And what's that trajectory? That trajectory is I want to sort of balance things out, to see if I can balance this out, y to be x squared. So if we let x be t, so I'm going to look at that, that's basically just a parabola. So let's look on this parabolic trajectory over here. Of course, that's less than the line if you're less than 1. So there's my parabolic trajectory number 4. And this is going to be what? X will be t. And if x is t, y is going to be t squared. And we're going to let t go between 1 and 0 over here. So let's look along trajectory number 4. So along trajectory number 4, what do we have? We have the limit as t approaches 0 of what? Of, let's see, my x is t, so it's going to be a t squared. Then we have a sine of y, but y is really t squared. All divided by what? All divided by t to the fourth. So I have a t to the fourth over here. And then I'm going to have a t squared squared. That's going to be another t to the fourth. So I have 2t to the fourth. So this is exactly just the limit as t approaches 0. Everything is a common factor. The numerator and denominator have a common factor of t squared. So I'll cancel the t squared. So I'm just going to sine of t squared over a 2t squared. Now I get 0 over 0 over here. So we can use L'Hopital's rule. By L'Hopital's rule, this is going to be the limit as t goes to 0 of what? Of the cosine of t squared. Cosine of t squared times 2t. All divided by the derivative of the denominator is going to be a 4t. So the t's are going to cancel over here, and the 2 is going to cancel with the 4 and turn into a 2. And as I plug in t equals 0, this I have the cosine of 0, which is 1 over 2. So the limit along this parabola is just 1/2. Aha, so we found a trajectory over here where the limit was not equal to 0, where it's 1/2. So I have two different trajectories where the limit on one trajectory is 0, namely the straight line, and another along the parabola where the trajectory gives me a limit of 1/2. Therefore, I have two distinct limits, so the limit does not exist. Thank you very much.